Welcome everybody. In this video we'll be learning about properties of determinants. So let's get started. So the number one property is that the value of a determinant remains unchanged if its rows and columns are interchanged. So let me explain it. For example, if we have determinant del is equals to 1, 2, 3, 4, 5, 6, 7 to 0. So now if we interchange it, suppose 1, 4, 7, we have converted the columns into rows. So 1, 4, 7, 2, 5, 2, 3, 6, 0. So now we'll expand this. This will be 1, 0 minus 12 minus 4 minus 6 plus 7, 12 minus 15. So this comes out to minus 12 plus 24 minus 21. This will be minus 9. So this is the value of this. Now we'll find the value of this determinant. So let us 1 5 times 0 minus 12 minus 2, 0 minus 42 plus 3, 8 minus 35. So this will be minus 12 plus 84 plus minus 81. This comes out to be minus 9. So the value of both determinants are minus 9. So let us move on to our second property, which is if the two consecutive rows or columns are interchanged, then the value of the determinants changes but only with sign. So again we'll take an example. So we'll take our previous example. We have our original 1, 2, 3, 4, 5, 6, 7 to 0. So now we'll interchange the value. So del 1, suppose we will take, this will be 4, 5, 6, 1, 2, 3, 7, 2, 0. What we have done is we have moved this second row to first row, and the first row comes down to second row. So now we get the value of this determinant. This will be 4 times 0 minus 6 minus 5 minus 0 minus 21 plus 6, 2 minus 14. This will be minus 24 plus 105 plus 72. This is equals to 9. So we had the original value of determinant was minus 9. Since we interchanged the rows, so the value of determinants remains same but only changes only with the sign. Therefore we can say del is equals to minus del 1. Now our third property, if the value of the elements of any two rows or columns are identical, then the value of determinant becomes 0. So let me show an example. Suppose we have a determinant a b c p q r. So since the two rows are same, the value of determinant always be 0. So now let us go on to the fourth property. If each entry in the row or column of a determinant is the sum of two numbers, then the determinant can be written in two different determinants. So let us see an example. A plus b plus q, c plus r. We have l m n o p c. So we can write this determinant into two forms: a l o b and p, c and c, plus b q r l m n o p c. We see that the determinants are separated. So let us move to our fifth property, which is the value of a determinant does not change value of determinant does not change if we multiply it by a constant in any rows or column. So this also holds for if we add or subtract, and if we add or subtract by a constant. So let me show an example. Suppose we can write, if our original determinant is a b c p q r u v w, so we can bring any changes in our determinant like this. Suppose we multiply the first column by k times a, we can add our second column to the first column plus b, then we can subtract third column and by multiplying it with the constant lambda c. So this will be right kp plus q minus lambda r. This will be ku plus v minus lambda w. So b q v c r w. So what we did is that we brought changes in column 1 c1 tending to, we multiplied c1 with k, then we added c2, then we subtracted lambda times c3. So we can bring any changes in our determinant by multiplying it or dividing it or subtracting or adding it by a constant. So now our sixth property: if all the elements above the leading diagonal element or below it or both are 0, then the value of determinant is multiplying the elements of diagonal. So let us see an example. Example del A0 0 B P 0 C R D. So this is called our leading diagonal element from our left side to right side. So we see that the elements above our leading diagonal elements are 0. So the value of determinant will be the product of the leading element, principal diagonal element. So A, P, T is our value for determinant. So let us see another example. Suppose your del equals to A, B, C, P, Q, 0, 0, and R. So again the value of this determinant will be A, P, R. So let us see another example. Suppose your determinant A 0, 0, 0, B 0, 0, 0, C. So again the elements above principal diagonal elements are 0 and below it also are 0. So the value of determinant will be product A, B, C. Let us move to our second property. So if the determinant becomes 0 on putting x equals to a, then x minus a is a factor of the given determinant. Factor of given determinant. So let us see an example. Example, we have determinant del is equals to x 5 2 x square 21 4 x cubed 16 8. So on putting x equals to 2 in C1, we get del 2 4 and 8, and we have here 5 21 16 2 4 8. Since C1 and C3 are identical, so the value of determinant becomes 0, and hence we can write that x minus 2 is a factor of given determinant. So that wraps up all our properties of determinants. So if you had any problems, comment below, and if you did like my video, hit the thumbs up button and subscribe to my channel for more videos. Thank you.